Assalamu alaikum wa rahmatullah. So I found here basically this moment again special to discuss one more problem in mechanics. But the problem I will try to discuss here, it belongs to the course of rotational dynamics. Okay. So let me first of all suggest here. Address here the problem. What basically problem is all about? If it is, if I will just uh, take the statement of the problem. Problem tells us if there is a rod, okay, the rod is consisting of, it has a length L, it has a mass M, okay, but the rod it stands vertically with respect some horizontal here. I'm just talking about the rod here, okay. If it has a length L and the mass M, it is aligned vertically with respect to some horizontal, means that its one end is pivoted with respect to the horizontal, okay. I am just trying to picturize the problem here. This rod, it has a length L and it has a mass M. The rod is symmetrical about its whole length, okay. And it's also given in a problem like the rod, it turns about its pivoted end here as if it falls under gravity. When the rod falls under gravity and it turns about this pivoted end here, if this is a new position of the rod, okay, I just draw here the dotted line. This dotted line represents the new position of a rod, okay. As the rod, it falls under gravity and it turns about its pivoted end, okay. When it reaches here, it makes an angle theta relative to this vertical, okay. The moment when it reaches here at some any instant of time, or I can say at some particular instant of time, it makes an angle 60 degrees with respect to this vertical here, okay. So the moment when it makes an angle of 60 degree here, okay, obviously when it falls under the gravity, it will achieve some angular velocity, okay. So but specifically when it reaches here at this instant of time, what will be the angular velocity of the rod, okay. I need to calculate basically the angular velocity of the rod when it makes an angle of 60 degree relative to this vertical alignment, okay. So one thing I can guess here, at the first place, that's very important thing here to analyze. The rod is initially at the rest, okay, under the gravity field. Obviously it will be associated with the gravitational potential energy, okay. But for that, when we talk about the gravitational potential energy, it depends upon the mass. When we talk about the mass of rod, no problem there are. Uniform gravity field, no issues there are. But at what height, what height I will just take here, if I will just consider this my reference for the potential energy calculation, but what height I can take it, although the rod has a length L, but what height I can take here, okay. So the height I will take here simply if I will just look to the system possesses a kind of symmetry. I'm just talking about this rod here. It has a symmetry about its whole length. So I think I can guess here more safely. At the first place, the rod possesses a weight, and that weight will lie definitely at its center, okay. If this rod has the geometrical center here, because wherever its center of gravity will be, that will be exactly at its geometrical center. Why so? Because a rod is symmetrical about its whole length. Hope you are getting it, okay. So when we talk about the initial most, if I will just look to the problem and see at the initial most position, what will be its energy? Its energy will be definitely only in the form of potential one, because rod does not move, rod does not allow to fall initially, okay. As time passes, it falls, okay. When it falls, it achieves some angular velocity, okay. I need to calculate here the angular velocity of the rod at a time when it makes an angle of 60 degree with respect to this vertical alignment and all that, okay. How I can approach here the problem of this type? This problem is basically based on what I can say, the conservation of energy. Total energy will be conserved here. Why so? Because the rod, it falls under the gravity force. When it falls under the gravity force, it is something that's known as gravity force. It's a typical example of the conservative force. Under the conservative force field, total energy will be conserved. Okay. So if I look to this system at the first place, my energy E1, yes, it will be in the form of potential, but the weight of the body that will lie exactly its geometrical center means that the weight will lie at halfway from this pivoted end. Okay, that will be mgl/2. Hope I mean you got it where from the things come and all that. Okay, so the moment when it reaches here at this particular situation here, the centermost point of the rod, it will not change. Okay, if this is my centermost point, it will not change, but the potential energy at this case will be definitely less, because total energy should anyway conserve here, and at this position rod is not at rest, but it achieves the kinetic energy. Okay, that's although the kinetic energy of rotation, no issues there are, but I can safely say at the later case the potential energy will be less. Okay, why so? Because this was the potential energy at the halfway of this rod here, that's this much, but the center point, it will not change, but it will be at a height of less than as that of the case first. Okay, means that this point will be right now at a height less than height L/2. Okay, as we know, if this represents the centermost point of the rod in the initial state, again this is the centermost point of the rod. Okay, so this much will be here, again L/2 from here to there, but this height will be, yes, if I will just assume that the height from here to there, it will be h. Okay, now this height will be simply L/2 minus h. Okay, hope you are getting it. Okay, it's simply something I'm just introducing here the new factor, that's h. H is the decrease in the height in the case second. Obviously this leads in the decrease in the potential energy. Okay, but at the same time there will be the increase in the kinetic energy. And in the case first, there was zero kinetic energy because the rod was initially at rest. Now as time passes, the rod, it falls under gravity. At the later case, we'll have the both forms of energy. If I will just say that energy in the situation second means that when my rod, it makes an angle 60 degree with its original, with its initial alignment. So in the case second, my total energy will have both parts, kinetic as well as potential. Okay, so the potential energy in the case second, it will be again mg. Mass does not change, there is a uniform gravity field, but the height is right now here, it will be L/2 minus h. Okay, and this is the new height of the centermost point of the rod, at which the whole weight lies. Okay, and plus there will be, yes, kinetic energy of rotation. As you know from the definition of the kinetic energy, it is 1/2 of m square. But it's a typical example of the rotational motion here. Now, I have the kinetic energy type, that will be the kinetic energy of rotation here, and that will be 1/2 has no rotational analog, it will be 1/2, and m has the rotational analog of as I, and the v has a rotational analog of omega. Okay, where I is the moment of inertia. As you know, it's a rotational effect of mass, and this is an angular velocity. Okay, so I can write here my kinetic energy of rotation, it will be 1/2 of I omega square. Okay, this is the energy that I have in the later case, but it's a gravity force, and gravity force conserves the total energy. I can safely write here my E1 will be equal to E2, no issues, because of energy conservation. Okay, will hold here as the force is a conservative one here, so my E1 will be equal to E2, so After doing further maths, I will get here mg L by 2. It will be mg is L by 2 minus mgh plus 1 half of I omega square. Okay, this will go with this, and if I will just put it here, what I will get is, I will get here simply mgh, it will be yes 1 half of I omega square. Okay, this is a moment of inertia of this rod. Okay, but this rod, it turns about this pivoted end. Okay, when this rod, it turns about this pivoted end, it will have the rotational effect with respect to this much. Okay, in this point, this pivoted end here, and how much the moment of inertia of this rod, that it turns about this pivoted end. So I can use here what I can say, the theorem of parallel axis. Okay, to know the moment of inertia about the axis or about this end. Okay, I will take here one axis, I will draw one more axis here, that will be, I mean, perpendicular to it, and we have the two parallel axes. I can have the distance L by 2, mass is given. Okay, but at the centermost point of the rod, my moment of inertia is known, but I can use here, I mean, and directly that result as well, without, I mean, caring here much, because that result is something that's known to me, that's ml square by 3 omega square. Otherwise we can calculate it, it's not a big deal here, but to save my time, I'm just directly going to use this result here. This is something, I mean, that's known to me, because to know the rotational effect about this pivoted end, it's better to use the theorem of parallel axis, and you can get this much. Okay, so here I will just look, it will be mgh, and this will go with this. What I have left with is this h is still unknown to me, but it's not again a big deal here to calculate. But for a moment, if I will just do here one thing, let me go for this unknown h calculation. I have introduced as before this h as unknown, because this was something, I mean, decrease in the height of the weight where it exactly lies. Okay, of a given rod and all that. So I can just calculate this. If this is here, from here to there, this L by 2. If this is L by 2 minus h, this will be also L by 2 minus h. Okay, this will be also L by 2 minus h, and this is L by 2. I can use here, hope you are getting it, it's something by using here geometrical argument, nothing else. Okay, I can use here L by 2 minus h, that's base or hypotenuse, that's L by 2, that will be cos of 60. Okay, that will be simply cos 60. So I will get here, yes, L by 2, that will be 1, and L by h over L by 2, that will be 2h by L. Cos 60 is 1 by 2. Okay, so it will be here, yes, 1 minus 1 by 2, that will be again 1 by 2. It will be 2h over L. Okay, my h is here, yes, my h is here L by 4. My h is here L by 4. By this way I got this unknown parameter, so I can, I mean, switch the value of it here. It will be L by 4, yes, it will be L omega square over 3L square. Okay, 1L will go with here, it is here 6. Okay, it's 2 2s, it will be 2 3s. So I will get here my omega square will be, yes, it will be 3 by 2 G upon L. Okay, so after, I mean, transferring this here, I will get 3 by 2 G of L. Okay, so this was something that was a demand from the question, what will be the, I mean, the angular velocity of the rod at a moment when it makes an angle of 60 degree with respect to the given vertical and all that. By this way my problem ends here. This was all about, I mean, this problem. Thank you.